All right, so picture this. You're chilling, right? You got a twin, identical the whole 9 yards, and let's just say one of you, just for kicks, decides to hop in a spaceship.
Oh, this is going to be good.
Yeah. And blast off into the great unknown at, like, practically the speed of light.
Okay, I'm hooked already.
Because then you come back, right? Back to Earth, years later. And get this, you're younger. Younger than your twin who stayed here.
Crazy, huh?
Oh, that's just messing with my head. It's wild. And guess what? It's not just some wacky science fiction plot. This is the twin paradox, and it's a real head-scratcher. So we're going to break it all down today. We're diving deep into this excerpt that digs into the what and the why of this whole mind-bending phenomenon. You'll walk away with a whole new perspective on, well, time itself. So to set the stage, this excerpt talks about these twins, Anna and Bruno. Anna is our fearless explorer volunteering for this crazy interstellar trip, leaving Bruno back here on Earth.
Right, classic twin setup.
Exactly. Now here's where things get really wild. When Anna returns from her epic space voyage, she's actually, get this, younger than Bruno. And this is where my brain starts to short circuit a little bit. How can two people born at the same time experience time so differently?
Yeah, it's one of those things that just throws you for a loop the first time you hear it. But that, my friend, is the crux of the twin paradox. It's like our everyday understanding of time just goes right out the window. And it all comes down to, you guessed it, Einstein and his theory of relativity. See, we tend to think of time as this fixed thing, right? Tick-tock, tick-tock, same for everyone.
Right, makes sense.
But Einstein, he threw everyone a curveball. He showed us that time, well, it's relative.
Relative, huh?
Exactly. Think of it like this. Let's say you're standing still and someone chucks a baseball right past you. To you, it's moving crazy fast, right? But to someone who's running alongside that ball at the same speed, it would look like it's barely moving, maybe even standing still. Time is kind of like that. It's not some absolute unchangeable thing. It's all relative to your perspective, your position, how fast you're moving through space.
Okay, I think I'm starting to get it. But how does this work with Anna and Bruno?
So the faster you move, especially as you approach the speed of light, the slower time passes for you compared to someone who's stationary. This mind-blowing concept is what we call time dilation.
Time dilation, that's got to be a mouthful to say at parties.
Right. So in our excerpt here, Anna's round trip, this epic space adventure to some distant star, it takes, say, 5 years from her perspective. But because she was cruising along at such a mind-boggling speed, 10 years could have zipped by for poor Bruno back on Earth.
So we're essentially saying that the very fabric of space and time is, like, warping, bending.
You got it. You're catching on quick. And here's the kicker. This isn't just some cool sci-fi concept we're throwing around. It's backed up by hard science. Scientists have actually done experiments with super accurate atomic clocks, flying them in jets. Now, these jets are going nowhere near the speed of light, obviously.
Yeah, that would be a little chaotic.
Just a tad. But even at those speeds, when they compared the clocks on the jets to the ones on the ground, guess what? The ones that were flying, they showed slightly slower time. Mind-blowing, right?
No way. Hold on. So this time dilation thing, it's not just some far-out space phenomenon. It's happening right here, right now, just on a much smaller scale.
You hit the nail on the head. And our excerpt here, it really hammers home this point. It's not some abstract idea. It's based on solid evidence, things we can actually observe and test.
I've got to say, that's pretty incredible. So let's say, just for fun, that we figure out this whole near light speed travel thing. What does that mean for us humans?
Now, there's a question that'll keep you up at night. Think about it. We could potentially hop over to distant planets within a single lifetime. The possibilities are endless. But it also opens up a whole Pandora's box of questions. If we can experience time at different rates, what does that even mean for our understanding of history, of aging itself? And what about the ethical dilemmas? It's pretty profound stuff.
Mind officially blown.
Glad I could help with that.
So there you have it, folks, the twin paradox. Time, as it turns out, isn't as straightforward as we thought. It's relative, it's flexible, and it can even make a twin jealous. Until next time, keep those brains buzzing.